Let's look at the next example for graphing. Same strategy. We're going to find our X-Intercepts. So if we let y equal 0, I think we could visualize that now after the first time. We're going to have x equals -1, 3, and 5. What's really important about this one, because there's a squared, that means that you'd have x equals -1 twice. So we're going to have a double root. That double root means it's going to bounce off the x-axis. So that's important when we are graphing this. There are 4 factors, remember, because this one occurs twice. So it is quartic or degree 4. That also tells me a little bit with the end behavior. It's positive. So when it's an even function, the arrowheads are going to go either both up or both down. Because it's positive, they're both up. So we say that it rises left, rises right. All right, we need the y-intercept as well. The y-intercept, we're going to let x equal 0. So we need to calculate that. So every time I see an x, I'm writing in 0. So I get 1 squared, -3 times -5. So this is going to equal 15. Okay, let's start plotting this. Now it's common to have an open grid like this rather than the actual grid. So we need to choose wisely here. So my x values, I can space this out. I can see I go up to 5. I don't want to squish them in too much. So 1, 2, 3, 4, 5. I need to go this way a little bit. I need at least -1. There's -1, 3. I usually label the x-intercepts. Now, the y-intercept is at 15. I don't know if I graph this and I need other points if it's going to go more. So sometimes I'm going to switch to pencil because I don't always know. I'm going to kind of just use sort of halfway on the graph. I don't necessarily know how far to go. So I'm going to just put 15 here. This doesn't have to be perfect with these sketches, but I don't want to put that at the top and then find out I need more. So I'm going to put 15 right there. And you don't need to draw 15 dashes in. You're going to just sort of estimate where that could be. So let's connect what we know so far. The end behavior is what I'm going to do next. So I go to my last x-intercept. It rises to the left. This is a double root, so it bounces. So that's going to go right through here to this point. I know that the end behavior on this side is going to go up. Now, I don't know if it's just going to go right through like this. And that's an okay sketch. But to be more accurate, I might want to test a point. I've done this lightly in pencil. I might want to test a point between 0 and 3. Whether I pick 1 or 2, you don't have to be perfectly accurate. We'll just pick a point. So let's test our x equals 1 so that we can be more accurate. We're not guessing on the distance here. So when I do that, I'm going to plug in 1 for x. So we're going to get 2 squared, or 4, times -2 times -4. So we're going to get, when you calculate this, you're going to get 32. So definitely it didn't go straight down. It went up quite far, in fact. Okay, so let's adjust this. I'm not going to bother testing 2. Might actually go further up, but let's say then this is 30. So it goes slightly above that. Remember my scale. And at least I have a little bit more accurate graph, okay? I don't want that too pointy. If I tested 2, it might go further up. You don't have to be perfect on this. Same thing here, though. I'm going to test between 3 and 5 because it's easy enough to test the point 4. So if I test x equals 4, I can get a little more accurate of a graph again. So 4 plus 1 squared, 4 minus 3, 4 minus 5. So 4 plus 1 is 5, 5 squared, so you're going to get 25 times 1 times -1, so we get -25. Okay, so of course it makes sense that it's negative. So that makes sense. If this was, we have to keep the scale. We can't just adjust. So about this distance was 15. This is -15. This is -30. So I'm estimating 20, 25, 30. So about here, you're going to do that. So again, this gives me a little bit better of an estimation. So I usually test a point or 2 if I don't know the distance between x-intercepts.